So in my write-up, I already sent you Rouche's theorem. So in this video, I would like to give some examples or applications of Rouche's theorem. All right. So let me recall first Rouche's theorem. So we had what? A simple closed contour, maybe positively or negatively oriented. So let us suppose it's positively oriented. And we had two functions, f, fz and gz. Okay, and those are analytic on and inside this. Okay, inside C, and the other conditions were there that modulus of fz is always greater than modulus of gz for the points z on C. Okay, on the curve. Then Rouche's theorem says that your fz and fz plus gz have the same number of zeros inside C. Same number of zeros inside C. Same number of zeros means your fz equal to 0 and fz plus gz equal to 0. They have same number of roots. Okay, this equation and this equation have the same number of roots. Right? So that is Rouche's theorem. Now this can be applied to find number of zeros or number of roots of these complex equations, some complex equations inside a curve. All right. So for example, so this is the example given in the book. So we have to find that how many zeros are there of this polynomial equation equal to 0. Okay, so this polynomials, or you can say that how many roots of these equations are there inside, say inside modulus of z equal to 1. So now what we will do, we will split this part into fz and gz type, so that I can conclude how many zeros are there for fz plus gz. So what fz you will choose so that you can apply Rouche's theorem. So suppose let us choose. So if we choose, so let us choose first your fz equal to say z to the power 7 and your gz. So let us choose the other one. That means what is this? 4z cube plus z minus 1. So now for these two functions, can I apply Rouche's theorem? Okay, so we have to find on mod z equal to 1, what is your modulus of fz? So modulus of fz is modulus of z to the power modulus of z power 7, and that is nothing but modulus of z to the power 7, and this is equal to, because mod z equal to 1 on C, so I have just 1. And what is your gz? Remember that for gz I have minus 4z cube plus z minus 1, and that is equal to, this is not equal because we have to now apply triangle inequality because this is this type. So I have what? This is minus 4z cube plus modulus of z plus 1. Okay, and what is this? So this is equal to this 4 mod z cube plus mod z plus 1. And what is this? So this is equal to, because mod z equal to 1, so this is 4 plus 1 plus 1, and that is 6. So that is what you got. So you got that modulus of gz is less than equal to 6. So I cannot say that we have what? Your modulus of fz, it should be strictly greater than modulus of gz, so that I can apply Rouche's theorem. But this is not the case, because modulus of fz is what? This is 1, and this is less than equal to 6. So I cannot clearly conclude that 1 is strictly greater than a number which is less than equal to 6. Okay, so this is 6. So this is not conclusive. Okay, so not conclusive, not conclusive. Okay, so therefore I cannot apply Rouche's theorem in this case, right? Because this is not, right? So therefore we have to choose fz in gz by another way. So how can I choose that? So you see that the function was z to the power 7 minus 4z cube plus z minus 1. This is the polynomial function, and we want to find the roots of this. So you see that the highest coefficient here is minus 4, okay, and modulus of z is 1. So therefore you need to choose what? Let we take what? Fz equal to minus 4z cube and your gz equal to the other parts. That means 7 z to the power 7 plus z minus 1. So now in this case on C, what is C? C is modulus of z equal to 1. We have your modulus of fz equal to minus 4z cube, and that is nothing but 4 mod z cube, and that is equal to 4. And on C, your gz equal to z to the power 7 plus z minus 1, and which is less than equal to mod z to the power 7 plus modulus of z plus 1, and that is equal to what? 1 1 1. So it is 3. So you see that modulus of fz is 4 and modulus of gz is a number which is less than equal to 3. So thus on C we see that we have your modulus of fz is greater than modulus of gz. Okay, so therefore, and these two functions fz and gz, these are polynomials, so it is analytic everywhere, and in particular it is analytic on and inside mod z equal to 1. So by Rouche's theorem, Rouche's theorem, your fz equal to minus 4z cube and fz plus gz. Remember that this should be added. And what is this? Fz plus gz. This is z to the power 7 minus 4z cube plus z minus 1 have the same number of zeros inside mod z equal to 1 inside, right? Inside means mod z is less than 1 actually in the region, right? And but I know that this fz, but fz equal to minus 4z cube has roots or has zeros. How many zeros? What are the zeros? The zeros of these are what? Fz equal to 0, and that is z equal to 0. So z equal to 0 and counting multiplicity. We have to count the multiplicities. So how many? 0, 0, 0. So 3. 0, 0, 0, 0. So that is 3. So therefore, so thus your fz plus gz has also how many zeros? So fz plus gz equal to z to the power 7 minus 4z cube plus z minus 1 has also 3 zeros. 3 zeros counting multiplicities if possible. Okay, counting multiplicities inside mod z equal to 1, right? So therefore that is your answer. So therefore we got that. Hence your z to the power 7 minus 4z cube plus z minus 1, these had 3 zeros, so I can say that these equation has how many? Has 3 roots. 3 roots inside mod z equal to 1. Alright? So that is the answer. So we have chosen fz in gz in such a way that it works. We can apply Rouche's theorem. Okay. So next I will again give another example. So how to choose this suitably for different situation.